So welcome back. So in today's video we are going to see a new project on machine learning, that is diabetes prediction using SVM. So before beginning, let's discuss about what actually SVM is. So to give you a quick idea, SVM stands for support vector machine. In this model, it is a classification model in which we try to divide two outcomes in either of side. Okay, so as you can see in this picture, we have two hyperplanes and we try to maximize the distance between these two hyperplanes. More the distance, more the accurate our model will be. So according to that distance, we find out the uh, decision line. Is this called decision line or a margin hyperplane? Anything on either side defines the target variable. That's the real quick guide to SVM. Now let's go to our data set. So it is our diabetes data set. You can download the data set from the Kaggle. As you can see, it has um, it has 9 properties: number of times pregnant, glucose level, diagnostic blood pressure, etc., etc. You can see here all the columns: glucose, skin thickness, insulin, BMI, age. All these factors can result to a diabetic patient or non-diabetic patient. These all are necessary. So you can download it here from here and just upload it using this icon. Here I have the diabetes CSV. So let's do some coding. First I will import all the libraries. It's always better to write text so that it can be more readable. First I will import pandas library. Sorry, input pandas as PD. Import numpy as np. Import, no, I have to import now of sklearn dot model selection. Let me just increase the size first. That's good. Selection, import train test split from sklearn, import SVM. Now from sklearn dot metrics, yes, I have to import accuracy score. Next I will have to import from sklearn dot preprocessing, import standard scalar. Okay, just it's going to be low. That's okay. Now I will run it. To run a cell, you have to type shift plus enter at same time. Okay, then I will explain all these libraries. Just give me a minute and I will import, say, load diabetes dataset into pandas data frame. So diabetes data is equals to pandas pd.read, then diabetes dot csv. If I'm, okay, it might be a sentence. Read csv. Now print first 5 rows. Diabetes data dot head. So as you can see, we have all the columns here. So let's explain. So first one is the pandas. So pandas is a Python library which is used to define array. Sorry, which is used to load the data frame into a table. The next one is the numpy. Numpy is used uh, to manipulate the arrays. It is faster than normal arrays and more efficient in terms of resource management. Moreover, you can have extra functionalities if you use numpy array. Now the next one is train test split. So it is also a Python library which is used to split data into two parts. The first one could be train dataset, and the second one would be test dataset. And fourth is SVM, that will use to train our model. And fifth one is accuracy score, which will be used to define how accurate our model is. The last one is the standard scaler. So it is a Python library which is used to define all the data points into the same scale. So let me give you an example. As you can see here, all the data points are on the different scales. It has a scale of 0.627. It has on the 35. It has 35. So these all are on the same different scale. To make them on the same scale, we will use standard scaler. So now let's do some analysis on data. First, we will find number of rows and columns. So it would be diabetes data dot shape. So it has 768 rows and 9 columns. Now now we will print statistical measures. So it would be data dot describe. So as you can see, we don't have any null values. 768 has 768 rows, and every column has 768 rows. That's good. So we do also have the mean, that all the mean of pregnancies column is 3.84. And let me explain that 25%, 50%, 75% means that 25% of the values are less than 1, 50% of the values are less than 3, and 75% of the values are less than 6. It has the maximum of 17, and minimum value of 0. Okay, now moving further. So now we will count number of target variables. So as we can see, our target variable is 0 and 1. 1 means that the patient is diabetic, and 0 means the person is non-diabetic. Okay, so we will diabetes data, and we will add the name of the column, that is the outcome dot value count. So it's a function just. So we have 500 patients with non-diabetic, diabetic, and 260 patients who are diabetic. Okay, so let's write it here. One means diabetic patient and 0 means non-diabetic patient. You can just add a enter. Okay, so in the next line. Great. Now next, let's see. Let's group by these data. I will tell you what is the significance. Yeah, dot mean. So as you can see that the person who is not diabetic in nature has pregnancy rate of has a mean pregnancy value of 3.2, glucose value of 109, and so on. Whereas the person who is diabetic in nature has mean pregnancy value of 4.8 and glucose values of 141 and so on. So here we can easily distinguish between the two of them. So we can draw a hyperplane. So that is why we do all the statistical measure to know what model we can use. You can use logistic regression as well. Now we will separate the data into training and test. So before that we will separate data and the just enable it so that we can do it. Separate the data and the label x is equals to diabetic data dot drop. If we will drop the last column, that is the outcome column, where it is, yeah, and which is the outcome column, and all these columns excluding outcome will be stored in a variable x, and the outcome column will be stored in the variable y. So here, so it's correct. So we will, yeah, it's correct. Now we will print x and print y. So as you can see, when we printed x, so we have all the columns excluding the outcome column, and in the y we have only the target column, or you can say outcome column. So target column is nothing but the outcome column, or you can say the output. Now we will standardize our data. Standardization, just keep it bold, right? So scalar is equals to standard scalar. Yes, standard scalar. X is equals to, so also scalar dot fit. Now we will fit our data, that is x. No, we will use only x, and standardize stand starter scalar transform max. Great. and then we will print standardized data. Okay, so let me explain. First of all, we load our object to a variable called scalar. Then we will fit our data, that is the x contains all the columns excluding our outcome. So it will learn, it will try to figure out what are the figure out and put all those data points into the same scale. Then we will transform all the data and store it to the standardized data. So as you can see, when we print it, all the outcomes are on the same scale. Now we have update our x as standardized data, and ny is summary is equals to outcome. That way we did earlier. Okay, then. So we updated our x and y was saved, but I did because just to double sure. Okay, now we will print our x and y one more time, just double check. So yeah, y is 0 1 0 1 0 1, that is the target variable, and x is our all the 7 columns. Great. Now we will split our test and training data. So we'll x train, x test, y train. Yeah, we will split into 80%. So 20% will be our test data, and rest of the will be the training data. Just compare it. Now we'll print. Let's print the rows. So originally our data frame had 768 rows, but after splitting, our training has 640 rows, and our test data has 154 rows. Great. Now we will train our model. Training model. So classifier is equals to SVM dot svc. Yeah, that's good. Now we will training the support SVM's support vector machine. Classifier dot fit. We are fit x train and y train. Okay, so we are training our model here in this step. So just try to learn what are the it's basically drawing the graph, the SVM graph, and try to distinguish between the data points. What is the model is doing? It is putting the values on either side and distinguish between them. Okay, now let's go here. Now we will do a model evaluation. And we will find our accuracy score. Okay, so first we will find our accuracy score on training data that we already trained for. X train accuracy is equals to classifier dot predict, and that accuracy score, and then we'll print accuracy score of training data is this, training data accuracy. So our accuracy score is 78%. That is good. Anything above, any score above 70% is good. So what we did, first of all, we try to predict our data using training data that we used to train our model. Okay, that score is put it into the X-train accuracy, and then we find out our accuracy score using the accuracy score library. Here we put out the accuracy score that our model predicted, and originally what was the output. It will match all the rows. Then it will find out the percentage. So our percentage is 78%. Great. Now similarly, let's find out the accuracy score on test data. X test, yeah, it's similar to what we did earlier. It should be, yeah, it's 77%. Great. So both of them are near to each other. That is great. So our model is working fine. If you want to do an uh, extra problem, you can go for logistic regression and comment me what would be the accuracy score if you use logistic regression. You can check logistic regression video in my playlist. Making predictive system. First of all, we use our input data. Data is equals to, we do it, then we will cast our input data as numpy array, yeah, and then we'll reshape. So why we use numpy array? Because all the data should be in the form of the array. So we will cast it using np.asArray, and then we will reshape it. Why we are reshaping is because we are predicting it for a one record. Okay, then we will standardize standardize the input as we did earlier. Standard data scalar or transform. Standard data is scalar transform. Yeah, we don't need to print it. Okay, then prediction is equals to classify.predict. That's correct. If prediction of 0 is equals to 0, then we will print person is non-diabetic, and this. Great. Now we have to put a, let's open with notepad, just go there and print any. Suppose I'm putting the second row, just go there and print it. The answer should be the person non-diabetic. So our model is working fine. Thank you, thanks for watching, and don't forget to like and subscribe.